Yeah. Hope my screen is visible.
Just a
Hello.
minute. Yeah, just a minute. Yeah, it is visible. You just log into your NPTEL portal.
Actually, so, so where is this? This is the NPTEL portal I have logged in.
Hmm.
Where I can get it?
You just go to that courses, which
All, all.
hmm. You just check your course. This is data analytics with Python, right?
Yeah. So where I can see that I was not getting actually.
Whether you registered for that course.
Yeah, I have registered actually. Uh, this is the thing I am getting all every day,
Okay,
and I
okay. Then
actually today I got time, so I joined today.
that's okay, fine. Anyhow, I will share that link to you. Okay. Whether
Okay.
you are following that recorded NPTEL videos or not.
No, so that where I can see that I was my question actually, where I can get the recording sessions and all.
Oh, that also don't know. Okay, yeah, we'll do one thing. Uh, you just go through all courses.
This one, no?
Yeah, go to course. Yeah, click on that. Go to course. These are the week 0, week 1. These are the recorded lecture videos.
Okay.
So far, I think 8 weeks are completed. Then at the bottom,
Actually,
problem solving session are there, right? These are the
okay.
live sessions. Okay, we are not taking
Mm-hmm.
exactly the same thing. We will give some additional information, or else we will clarify some doubt. For example,
Mm-hmm.
you asked some doubt, right? Like this, the live sessions are a bit different than the recorded lecture videos.
And what are the tools been used in this session? Like actually, I had used Anaconda. So what is the tool? Anaconda and Jupyter Notebook.
Yeah, you can
Uh,
use Anaconda and Jupyter Notebook. It's no issue. But I am using for Google Colab for demonstration, Python
okay,
demonstration.
okay,
Mm.
okay, okay. Fine, fine, fine.
Mm.
Okay,
You
I'll
just
see
click on that
today.
link. You go to bottom and then click on that problem solving session. Yeah,
Problem.
here, yeah. You just again click
This
on
one.
some link. Yeah, either first one or second one. You just, I think maybe first one. Oh.
This one problem.
No, no, no. Here it is there now. Go top. Click here is there, right?
Click.
Right,
Okay,
yeah.
okay.
You just click on. So this is the sheet, okay. These are my live sessions. Then there is another PMRF TA is there.
Mm-hmm.
These are recorded videos of her, okay. And then we have
Mm-hmm.
folders. If you want to access this material, we created folders.
Okay,
Now
okay.
you can able to access my material here, okay.
Mm-hmm. Okay.
If you want to
Actually,
go through,
I had a lot. My office was a bit long time, so I have missed like a long like. How like total 12 weeks we have, and I have missed around 6 weeks, right?
yeah, that's okay, fine. Whenever you have free time, you just go through these videos, and first you go through recorded NPTEL videos, then you come to these sessions, live sessions, because
Okay,
you need
okay,
to have a
okay.
bit of basic knowledge, okay.
Hands on and yeah.
If you understand those basics, then only you will understand these live sessions, because we will directly teach some concept. We won't teach basics
Mm-hmm.
and all.
Yeah. Okay. Okay. So till week 12 means till April end. I think it will be happening. I
Yeah,
hope.
yeah.
Oh. Okay. 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 Fine. 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 Okay. So your good name is
My name
uh,
is Ambati Ramireddy. Yeah.
okay. So any queries if I have and I want to connect with you, so I can mail you. Is there any email ID or anything from your end?
Okay, I will share my LinkedIn. Okay, you can
Yeah,
message
LinkedIn
me.
would be LinkedIn would be good actually.
Uh, if you have any queries,
Uh,
you
just a
can
second.
text me. Okay.
Yeah, yeah, sure, sure, sure. Uh,
Any
yes,
other things you
spelling.
want to know?
No. Uh,
Okay, you just check the chart. I shared my LinkedIn profile.
so any your profile is not showing up actually.
No, you click on my profile. No?
Which one? That link.
Yeah,
This one,
in
right?
Google Chat. No, no, not that one. In Google Chat, I shared my page, LinkedIn page.
Okay. Okay, okay, okay. I didn't had a look actually. Okay, okay. Yeah, I shared you the link actually. Yeah, I shared you the request actually. I hope you have received.
Maybe. Okay. Anyhow, I will connect. Yeah, I received.
Yeah.
Okay, you have any other questions?
No, no, no. If I have, I'll start right now. Actually, I have missed a lot. Like I have just kept, I had planned like I no more missing. I have to give my 100. So everything is connected to YouTube, right?
Yes, all the
O-
materials, it will be there YouTube and drives. Okay.
Okay,
Um,
okay, okay.
you can able to access all the materials from your course page, NPTEL course page. Yeah,
Mm-hmm.
these are the recorded videos, and then at the bottom we have live sessions. Okay.
Big zero. Okay, there's a practice assignment. Okay, I am in the practice assignment. Recording will be where actually?
Bottom problem solving session.
Okay, this is the like total class and all. Everything is in this link only.
No, no. These are the live sessions done by TAs, like teaching assistants. The
Uh,
actual faculty recorded videos are there. In you just click on week one or week two.
week one.
You just go to you click on that one, Python fundamentals. Yeah,
Okay,
you
okay,
can able
okay,
to access here.
okay, 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 okay. Got it.
Mm.
Okay, this is the session thing and
Yeah,
all,
for
right?
every week you may have 3 4 sessions. At the end you may have assignments. Okay,
Okay,
and
got
then
it, got it,
solutions.
got
Okay, you need to go through those as
it.
well.
Mm-hmm.
Okay,
Okay, okay. Yeah, thank you.
okay,
I'll just
thank you.
anything. I'll just get back to you.
Okay, sure.
Yeah, thank you.
Mm.
I'll just send stop sharing.
Okay,
Oh yeah. Where's the stop
can you just
sharing option?
stop?
Yeah.
Okay, thank you. Can you please mute by yourself?
Yeah, sure, sure, sure. I'll do that.
Hi, good evening all. So I hope this will be week 7. Week 7 live session, right? Okay. Think in the session we will see two concepts. Okay. One is chi-square test and then ANOVA test. Okay. Initially we will see some fundamental theory. Okay. Later I will demonstrate with Python. Okay. Let me share my screen. Okay, I will explain briefly this theory. So I hope the Professor Ramesar discussed about this chi-square test and ANOVA test in the past live recorded videos. Okay. So anyhow, I will cover a few basics and then we will move on to Python demonstration or implementation. Okay. So before that, do you have any specific questions? Because this is the live sessions. Actually, the live sessions are meant for if you are having any specific questions, we need to give some inputs to you so that you can improve by yourself. So if you are having any specific questions, you will just tell me. Otherwise, I will move on to chi-square test and ANOVA test. Is there any questions? Okay. 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 I believe that you don't have any questions. Let me explain this thing. Okay. So in which scenario you are going to use chi-square and which scenario you are going to use ANOVA test? Do you have any idea? Can you please, someone will respond. When you prefer chi-square test and when you prefer ANOVA? See, so far we have seen some data sets and the data sets having different features. Okay, feature means the columns, right? So in which case you will prefer chi-square test? Any idea? So for example, if you are having a categorical types of features, okay, categorical types of features means like for example um, gender, okay, whether male or female, okay, then which class you are belongs to, you are belongs to class 10, class 11, class 12, okay. So these are the categorical related things, okay. So if you are having a categorical features, you need to know the relationship between those two features, okay. Or else you need to associate, you want to know what kind of association between these two features, okay. Like I told, okay, gender and class 10, I mean class, okay, which class the particular student or the particular person is studying. So in gender you have two groups, okay, generally male and female, and then you are going to have class 10, class 11, class 12, okay. So if you want to know the relationship between these two kinds of categorical feature, you are going to prefer the chi-square test, okay. But if you are having numerical kind of data, okay, so then that case you are preferring the ANOVA, okay. Again in ANOVA test, if you are having two or more groups of data, so then you can prefer the ANOVA. Again you may have different types of ANOVA test is there, okay, ANOVA 1, ANOVA 2, ANOVA 3, like that, okay. So first we will see chi-square test, okay. So this will be the some kind of news, okay. Researchers found a 9-fold increase in the risk of developing Parkinson's diseases. I mean, this is the kind of disease, okay, in individual exposed in the workplace to certain solvents, okay. So this is the news, okay. So what is this news means? These researchers are found a 9-fold increase in the risk of developing a Parkinson's in individuals exposed in the workplace to certain solvents, okay. So what do you want to know is the in workplace this kind of diseases are increasing, okay. You need to classify whether the particular person or guy is having Parkinson's disease or not, okay. You want to classify, okay. You want to provide the labels as either this Parkinson disease, yes or no, okay. You need to categorize this thing, okay. So okay, so that is one example, because we have two kinds of binary data. One is yes, another one is no, okay. So let me see, okay. So you just come here, okay. So what is the outcome of all these statistical tests are meant for, okay. So if you observe here, the outcome variable is all these statistical states, okay. This may be binary or categorical things, like you need to know whether yes or no. For example, if you got fracture or if you got hurted, okay. So you need to classify it as yes or no, okay. So again, are the observations correlated? You need to check what kind of correlation is there among the data available in the data set, okay. So you want to know. So these are the some of the tests, okay. Anyhow, we are not covering all these things, but let's see, okay. For example, chi-square test is there. If you want to compare proportions between two or more groups, okay. So you need to compare two or more groups. You can prefer the chi-square test. Again, this will be the independent, okay. It won't depend in the futures, okay. So it's going to have independent nature, okay. So for example, in some cases you are going to have your data set, so and then you have two features, okay. So in that case there will be some dependency will be there, okay. So for example, you have a column or a feature called date of birth, okay. Then you need to know what is the age of that person, age of the person or age of the candidate, okay. You want to know, it means can you able to derive the age of the person from the data, I mean from the date of birth, right? So if you know one feature, if I know date of birth, I can able to derive the or I can able to get the age, okay. So that is kind of independent, okay. So I mean that's kind of dependence. So this chi-square is independent kind of data you are having. So these are the different tests, okay. As of now I am just following chi-square tests, okay. I'm giving and then you are going to have, okay, I told ANOVA is there, right? So this ANOVA is the outcome of this ANOVA test is it's a continuous, okay. So like continuous means whether if you got fracture, okay, so then what will be, is there any pain is there, okay, is there any scale or anything it is affected your body or any cognitive function, okay, like any brain damage or any kind of functionality like hand movements, leg movements, whatever it is, okay. So anything, okay. So whenever you are having numericals, okay, and then you are having continuous outcomes, okay, in such cases you are going to go for ANOVA. So in this session we will see chi-square test and then ANOVA, okay. This ANOVA compares means between more than two independent groups, okay. So this is the concept, okay. Let's see one by one, okay. First we will see, I think ANOVA full form is analysis of variance, okay. You already know what is the variance. So first we will see uh, chi-square test, how we are going to implement chi-square test in Python. Then we will come to ANOVA, okay. So this is a chi-square test for comparing proportions. If you are having a categorical variable, then you can prefer the chi-square test is, I think previously we discussed, this is kind of independence, okay. So when you want to predict or when you want to know outcome of variables, okay, you can prefer the. So in this chi-square test, okay, you are going to use one concept called cross classified, okay. So you are going to use contingency table, okay. Later I will see, okay. I will show the demonstration what is this contingency table, and then you can see, right, cross table or classified, okay. So they may be cross classified in contingency table and compared using chi-square test of independence, okay. So the contingency table will be with R rows and C columns. So you are going to have R into C contingency table, okay. Then we will see one example for this. See here, okay, this is the chi-square test. You need to confirm this will be and then number of groups. Okay, we are going to have a data like this. Okay, number of group members means here group members are 2, 4, 6 and 8, 10. Okay, you are having this kind of data, and then you need to know whether they are confirmed or not. Okay, yes or no, and then we have some values like this. Okay, so what we are basically doing is, so initially we need to sum up these things. Okay, confirmed yes, and then you are going to have no confirmed. Okay, so then I think you know this formula, right? So this is the chi-square test formula. Chi-square equal to summation of observed minus expected whole square by expected. Okay, so this is the uh, chi-square test formula. So we are going to have some observed and expectations. Okay, so you just use these values. Okay, so and then okay, so what is this degree of freedom means? You need to subtract number of rows minus 1 multiplied with number of columns minus 1, so you will get the degree of freedom. Okay, so that is the formula for chi-square test. Okay, now what we will see is I will show how to implement this chi-square test in Python. Okay, then based on this chi-square test, okay, what we will do is we will try to uh, reject, or we will try to accept some hypothesis. Okay, this chi-square test also used for hypothesis testing, right? So let me share my Colab notebook file. See, based on the chi-square test concept, okay, now I am trying to implement that chi-square test in Python. Okay, so see here, chi-square test basically used, the test is applied. Okay, the test is applied when you have two categorical variables from a single population. Okay, it is used to determine whether there is a significant association between the two variables. Okay, so that is I mean variables in the sense means here it is features. Okay, so to implement this chi-square test we require the necessary libraries. Okay, so of course this is comes under statistics. Okay, you need to import the statistics library from scipy. Okay, import, you just import this library scipy.stats as stats, one of the library, then seaborn and pandas and numpy. Okay, so and then what I'm doing is I am taking the one data set which is already there in the seaborn. Okay, this data set is already available in the seaborn. I mean I already told, okay, there are some libraries they have some existing data sets. Okay, if you want to work on few examples, you need to import the respective data sets, and then you can able to work, or you can able to uh, test those concepts. Okay, so now I think in last session also I told how to load the existing data sets means you need to import the respective library, this pandas. Okay, this data set, tips data set is available in pandas. You just seaborn, it is available in seaborn with the help of that name. Okay, SNS means this is alias names. So with the help of this name, you load that data set. Okay. For loading the data set, you need to use the syntax as load underscore data set. You just give that name. Okay. So you try to execute this data set, it's can able to load. Then if you want to view that data set, you just call dataset dot head. Okay, so you can able to see some data. Okay, initially this will display by default 5 records. If you want to more, you can give, okay, the number, how many records you want. Okay, so for example, now if you want more records you want to view, you just give like this. This is the data set. What is this data set is meant for is, okay, so in this data set, okay, this is the billing. Okay, tips means like if you went to some hotel, you can give some kind of tip, right? So they are going to maintain the total bill and then tip. So and then gender is the one of the column or feature. Okay, so here in size code test you are going to consider this as variables also. Okay, so this may be feature, variable, whatever it is. Okay, so total bill, tip, and then you are going to have gender, and then smoker, day, time, size. Okay, so you are having this kind of features or variables. Okay, so from this, okay, so what you want to know is, so you need to check whether is there any relationship is there between these two features. Is there any relation between gender and smoker? Okay, so for example, is there any condition if the gender is male then they can smoke, if the gender is female then they won't smoke? Is there any such kind of rule or condition is there? You need to check that kind of uh, you need to check that relations, right? So for that, so this is my data set. So you can take any two features or variables. So from this, okay, after you just form the some table. Okay, previously you have seen some contingency table, right, in theory. Okay, so what is that contingency table is showing is, so it is going to, you are going to form a separate table, that is dataset table. So then you are checking cross tab. Okay, cross tab means you just, if you want to know more description about these things. Okay, so we have two features, one is sex and another one is smoker in our existing dataset. Okay, here we have these two features, right? So what you will do is, you just pass those two features or variables to cross tab. Cross tab means, okay, this is one particular feature, this is another. Okay, so then you just form or you create the contingency table or data set table. Okay, here I am going to call it as data set table. So I already told, okay, whenever you are going to have a data set, if you want to do any kind of data manipulations, initially you need to load them into a data frame. Okay, for that we need to use pandas library. Okay, so we just try to execute this one. So what we did is, so we have created a separate table, like that is smoke and sex. Okay, in sex we have two different types of people, male and female. So we are maintaining that categorical values. Okay, these two are two categorical variables. One is smoker, yes or no, another one is sex. Okay, so in this data set we have 60 male, they are smoking, 97 male, they are not smoking. Okay, that is the meaning of this particular table. Okay, so is that clear how I formed this table? So whenever you want to form a separate table, you need to use cross tab and then you can form the some contingency table. So in this case it is a 2 by 2 matrix, or you just call it as 2 by 2 kind of uh, variable data. So you have two categorical values, one is smoker, another one is sex. Smoker means yes or no, and then again sex. Okay, this is the statistics that are present inside this data. Okay, so we are going to form a new table from the existing table. Okay, then you need to know the relationship between these two things. For that you need to use chi-square test. After that you just load those values. Okay, you have these two values. These are the 2 by 2 values. Okay, you have two rows and two columns. Then we already explained what is that observed values and then expected values, right? You need to know initial observed values. So these are my initial observed values from this contingency table or data set table. We have observed these values. Okay, so that is 60, 97, 33, 54. Okay, now what I am doing is I am trying to form full contingency table with the help of stats dot. You call this function whenever you want to form the contingency table. You need to call this function chi square. Okay, so contingency, you just go through this description. Chi-square test of independence of variable in a contingency table. This function computes the chi-square statistics and p-value for the hypothesis test of independence of the observed frequencies in the contingency table. Okay, that is observed. Okay, the expected frequencies are computed based on the marginal sums under the assumptions of independence. Okay, see this in scipy.org. Okay, there will be more explanation will be there. So as of now you just go, you need to use this contingency table, then you just click on this value. Okay, so these are the values. Okay, so if you click on this value, okay, see what we did is we are using the existing contingency table from the data table whatever you created here. Okay, these are the observed values. With the help of that you call this one. Okay, then you can print this value. If you print this value, the chi-square contingency results are the static is 0, p-value is 1, then DOF means degree of freedom is 1, then the expected frequency. Okay, it is giving some values. Okay, so 59, 97, 33 and then 53. If you observe here, these are the expected frequency. If you observe original values, these are my original values: 60, 97, 33 and then 54. Okay, so now you have expected values also. So how you are going to get all these values means, if you call this function, you can able to get all these statistics. Okay, static p value, degree of freedom value, then the expected frequency values. Okay, so now you just take the number of rows you are going to have. You just compute the degree of.
So, e
All of you, can you please mute by yourself? Can you allow calculator for exam hall? Or if yes, they will give virtual calculator. I don't know whether you are having experience of writing online exam. Okay, in computer system itself you may have online calculator. Okay, see then you need to compute the number of rows. Okay, and the number of columns. Okay, this is the how you can able to compute. Okay, so you want to know how many rows are there, you just give that length. Okay, so why we would need to know these number of rows and number of column means, because you need to know, you need to compute that degree of freedom value, right? So for that purpose, the degree of freedom value will be number of rows minus 1 multiplication into number of columns minus 1. Okay, so with the help of these values you just compute the, and then you are giving alpha value. So your alpha value you are going to assume it as 0.05. Okay, so you will get the degree of freedom is 1. Okay, if you observe here, here also it will be DOF is 1 only. So now what we will do is, I think you already seen chi-square test formula. I am writing, I am showing the Python code for the same. Okay, so this is the Python syntax for chi-square test. Okay, so if you want to compute chi-square test, you need to import this chi2, okay, this chi2 function from the scipy stats. After that, chi-square equal to, you have seen, right, what is this formula? Summation of observed minus expected whole square by expected. Okay, and then whatever the values you will get it from here, you are going to zip those values. Okay, uh, so this is the chi-square formula implementation. Then you just print that chi-square static value. Okay, you will get output here. You try to print this one. Okay, so you are going to have your chi-square static will be 0.0019. Okay, this is one way. Another way is, okay, so you already know, this is one way. With the formula you can able to compute directly this chi-square value. So there is another way also there. Okay, what is that other way is, so you think you know how to compute CDF and all. Okay, from that, like cumulative distribution. So this is inverse of, you can compute the PPF. How you are going to compute PPF means, that is q equal to 1 minus alpha. Your alpha is here, you will get your alpha value. Okay, this is my alpha value. You just use the q equal to 1 minus alpha, then you can use degree of freedom. Okay, you can get the critical value. Okay, so one you are going to have chi-square static value, another one is you have critical value. Okay, so from this you just compute p value, level of significance, all these are my parameters. Okay, so what we will do is, basically you need to know, okay, I am computing two values, one is chi-square static value and then critical value. Okay, so from these two values I am making my decision. For example, if my chi-square statics is greater than or equal to critical value, what I am telling is, you reject the hypothesis, this is null hypothesis. There is a relationship between two categorical variables. Okay, so initially, for example, initially we have assumed, okay, our h naught will be the two categorical values. What are those two categorical values? 6, and then what is another variable we have considered here in this example? We have taken two variables. Okay, smoker. Okay, so the variable name is smoker. Initially I am going to assume my null hypothesis will be having a relationship between these two categorical variables. Okay, this is my hypothesis. Okay, where then you applied that chi-square computations. Okay, you are trying to calculate chi-square static value and critical value. Okay, so you know how to compute this chi-square static value, means based on that formula, chi-square equal to observation minus expected whole square by expected. Okay, that is summation. Then how to compute critical value means 1 minus alpha. Okay, from that formula 1 minus alpha, you are computing these two values. If chi-square value is greater than or equal to, you reject the null hypothesis. Else you can say that there is no relationship between. Okay, so if this is not true, then it will go to the else. Okay, so with the help of these two values you can able to check. Similarly, you just use p value. You already know p value and alpha value for comparison. Okay, so either you follow this or this, both are same only. Okay, but if you run this one, okay, so you can able to for both the statements. Okay, here there is no relationship between these two categorical variables. Okay, there is no relation between I mean, is there any relationship between gender and smoking means, so there is no relationship based on this chi-square test. So that is the conclusion. Any questions? I think you know why we are using chi-square test. Okay. Okay, I will repeat one more time. Okay, you just follow me. I will repeat the the same thing again. Okay, because if you understand one example, then it will be easy for you. So just give me a minute. Okay. Okay. Let's see. Okay, I will explain one more time. Okay, so in this live session we are focusing on chi-square test. Okay, why we want to use chi-square test means generally whenever a real-time data or a data set is there means there will be so many records and then so many features or columns are there. Okay, like rows and columns are there. These rows are considered to be records, columns are features or variables. Okay, so what will happen is you need to test is there any relationship between these categorical variables. Okay, you want to test it. Okay, for that if you are having categorical kind of data you can prefer chi-square test. If you are having numerical kind of data you are going for ANOVA data. Okay, so I mean ANOVA test. So in this session I will explain the chi-square test which is meant for the categorical variables. Okay, so if you want to know the relationship between the two variables or two features. Okay, so for that I am just demonstrating this chi-square test using Python. For that we require some necessary libraries, that is scipython, cbone, pandas and numpy. Okay, so these are the default libraries we need to import from the Python. Okay, then what I am doing is to demonstrate this chi-square test I am trying to I am trying to use the existing data set that is present in the cbone. Okay, so we have one existing data set, tips is there in the cbone. So I am trying to load that data set. For loading I am using this data set is variable name, then with the help of this alias name sns dot load underscore data set, and then you just call the tips data set. Okay, so you can able to load this data set. Then you want to view the data set, you can view it. Okay, you want to know what kind of data it is having, so it is having this kind this is the kind of data that present inside these tips. Okay, so we have different features, different variables like total bill, tip, sex, smoker, day, time, size. Okay, so this will be the features. Now what I want to do is I want to know whether is there any relationship between sex and smoker. Okay, so I want to know because I gave one example, right? For example, if there is a male then he will smoke, or if there is a female they don't smoke. Is there any such kind of hypothesis or any kind of rule is there? No, right? So it won't depend on gender or it won't the smoking, it depends on their interest. Okay, so now you want to know test it. Okay, you want to test it using chi-square test. Okay, so for that we have this data set. From this data set what I am doing is I am trying to retrieve these two variables or features from this entire data set and I am storing that into some separate table. Okay, that is data set table. So to retrieve those things you need to use cross tab function, like you have different columns or tabs, right? So we are going to call it as cross tab function. You get the this feature. Okay, this feature from that data set and then this. Okay, we are getting these two features and you are trying to load this into data set table. Now you try to print that data set table. So this is the entire statistics of this table. So we have smoker two variables, yes or no. So if you observe this entire smoker, you are going to your values are either yes or no. Okay. So similarly you have two values. Then the gender. Okay, so you are going to have all these numbers. So there are 60 male people, they are smoking, 97 people they are not smoking. Similarly for female also 33 people are smoking, 54 are non-smoking people. Okay, then you just click on this data set table values. Okay, so these are your actual observed values, right? From the theory, okay, if you want to know more about that theory, like what is chi-score test, okay, ANOVA test, what you will do is I'll give one YouTube channel, okay. You just, okay, let me give you a minute, okay, I will give the resources to know more understanding about this theoretical part, what is chi-score test, ANOVA test, okay. So there is a channel called, what is this guy name is? Krishna Naik, okay. Um,
हेलो हेलो ऑल, माय नेम इज़ कृष्ण नायक एंड वेलकम टू कृष्ण नायक हिंदी यूट्यूब चैनल। सो गाइज, इस वीडियो में हम लोग डिस्कशन करने वाले हैं डेटा एनालिस्ट रोड मैप में जो 2023 में आपको फॉलो करना है, डेटा एनालिस्ट जैसे जॉब प्रोफाइल्स को।
so what you will do is if you want to know more about, see, if you want to know more about chi-score test and all, you can refer this channel, okay. Like for example, you want to know, see, he gave some tutorials like this, okay. You just refer this, maybe this may be useful for you.
हेलो
uh, you just
हेलो ऑल, माय नेम इज
there are so many videos, okay, like
हेलो
statistics
ऑल, माय नेम
related
इज
to
कृष्ण नायक एंड वेलकम।
chi-square, ANOVA, t-test, okay, whatever it is.
हाय सर।
So he gave different videos. Just refer those videos to know more about these statistics, okay. So then what we will do is you refer that. Now come to here, these are the observed values, right? So now you are having some observed values. From these observed values, okay, I am trying to form one contingency table, okay. So you, for that you already have contingency table implementation chi-score test. You just call that one. It can able to print some statistics, okay, like p-value, static value, okay, degree of freedom, then expected frequency, okay. So these are the contingency table result values, okay. So from this you are having expected values also. So after that what you are doing is you are trying to get the degree of freedom. You want to know degree of freedom, you need to check it, right? For to check whether this degree of freedom is correct or not, okay, you can use number of minus rows minus 1 into number of columns minus 1. This is one way to check the degree of freedom. Then what we will do is from the formula I am trying to compute chi-square static value and then critical value, okay. So how you are going to compute the chi-square static value means from the formula, that is summation of observed minus expected whole square by expected, okay, this is formula. And then you can store all these two results, observed values and then expected values. You try to print that value and then critical value. So how to print this critical value means that is 1 minus alpha. uh, you just compute the I mean inverse of CDF, inverse of cumulative probability function. Instead of that you may have PPF, you compute this value to get the critical value. So then you try to compare here, okay, chi-square value. If it is greater than, you just reject, okay, null hypothesis, okay, there is a relationship between two categories. So in this example chi-square is not greater than, okay, this is less than. If you observe here critical value is 3.84, chi-square value is 0.0011. This is less than, so that's why we are not, it is going for the next statement. There is no relationship between these two categorical variables. Okay, so that will be the chi-square test. Any questions? See, do you have any questions? If you don't have any questions, then what I will do is I will give some simple examples. Uh, can you able to use this chi-square test, and then you can give me the answer? Okay, so I am planning to give an example. See, now I am giving one more example for this chi-square test. Okay, just see here. To understand more about this thing, I am giving one simple example, which I am taking this from the GPT. Okay, so what I am doing is I am trying to, instead of data set, okay, I am creating one dummy data. So this is my data, sample data, like gender versus product. Okay, so for example, gender means you have male and female, and then product means you assume that there is some product. Okay, you assume it is laptop. Whether you like that laptop based on gender, is there any relationship between these two? By assumption, okay, or by imagination, can you say is there any relationship between gender and product? Can you able to say? Okay, what I'm doing is, this is my dummy data. Okay, 30 for, I mean 10, 20, 40. Then what I'm doing is we are trying to take the columns. Okay, so we have two different variables. Okay, like a dislike. So there are 30 male people, they will like it. 10 male, they don't like the product. You assume the product is laptop. Similarly, female, 20 people. This is some sample data. Now what we are doing is we are trying to compute that contingency from this data frame. Okay, contingency table. Okay, if you call this chi-square underscore contingency, then you can pass your data. You can able to get all these values: chi-square value, p value, degree of freedom value, then expected value. Like in previous example also we have seen the same thing. Okay, so see here also what we did is we already have this chi-square underscore contingency. We call that function, you will get all these values. These are my chi-square static value. Okay, then p value, degree of freedom value, expected value. Okay, so now tell me, based on this you just frame two hypotheses. Okay, so the first hypothesis is h naught. Okay, previous example also you have seen something, right? Similarly here also, if chi-square static value greater than, in previous example you have seen critical value. Okay, so in this case if it is greater than, you can make some decision. Okay, so in this example what we will do is, previously we have seen critical value, but in this example I did not computed critical value, but I know these values, p value and alpha value. Okay, based on that two things. Okay, what is my p value? P value is 0.0010. Then
We
alpha
will
value,
reject null hypothesis.
you are going to reject.
Null hypothesis.
The reason is p value is,
P value is 0.05 is the significant value, and the
yeah,
now
if you are
P
assuming it
value
as
is
alpha is
Yes.
0.05. So
Yes,
if
is
it
the
is,
less than.
yeah, so
That.
if it is less than, the p value is less than alpha value, so
Yes, sir.
you are going to reject, or you are
Check
going to
null.
make some decision. Okay,
Yes,
so
sir.
that is about chi-square test. Okay, so if you want to solve any example, okay, so I will give one example. You just take some time, and I will share one example. Okay, now what you are going to do is you just take this example. Okay, from this you can form two hypotheses. Okay, and then you can give your decision. Mm, I think I already explained this chi-square test, right? You take some 5 minutes time. Okay, you are going to have a similar kind of data. Okay, categorical data. Here it is confirmed yes or no, and then the number of group members. Okay, you have different types of data. From this you use chi-square formula. You compute the necessary parameters, then you can give me your answer in chat box. Okay, take 5 minutes time to solve this example. Okay, is that okay? You just take some time to solve this example.
Reddy,
Reddy, if you are in lab, you please take two paragraph notes on election commission. Take printout, and while you are returning to home, you give it to me, Reddy. Only two paragraphs is enough on election commission.
Done. So what is your conclusion from this example? See, you need to solve like this example, okay? The chi-square, so this is the solution, okay? The chi-square test, okay? Summation of observed minus expected whole square by expected, okay? So see, if you observe here, so these are the observed values minus expected whole square, okay? You will get 85, and then degree of freedom is you are going to get it as 4 from this example. So what you will do is, so you compute the value, p value, okay, or else chi-square test value, and then critical value, whatever it is, okay? You just form two hypotheses, then you can accept or reject this hypothesis, okay? You need to compute like this. Let me give one more example with Python. So similarly, we have like this, okay? We have a nation, okay? Then in our nation we have different languages, okay, like English, Hindi, Tamil, Telugu, okay? These are different languages, and other languages also there, okay? These many number of people, they are going to speak those languages, okay? So this is the data I'm giving directly to my data frame. I think you already know, you need this package. This is the data, you are going to have it, okay? See here, okay? And this cross table and all, you just use. This is my data, okay? So we have different languages, English, Hindi, okay? This is the count. The English, maybe this is some sample data. 1 lakh people, they will speak English. Some 60,000 people, they will speak Hindi and other languages, Tamil, okay? We have like this. Then what we are going to do is, so again you are going to maintain a count. What is this TN? You just tell me. This is national and this TN. What is TN? TN means like Tamil Nadu, okay? So what we are doing is, we have two different, this is state date, the short form for Tamil Nadu is TN. I am going to take, okay, inside Tamil Nadu state we have separate statistics like this, okay? So now the observed data in the Tamil Nadu state, okay, this is the observed count, these are the count you observed. Then you are going to have some national count also, okay? This is state count, and then you are having national count, okay? So now what you will do is, you need to compute some expected values, okay? You can use expected equal to national ratio. Initially you just compute the ratio, national ratio. How you are going to compute the ratio means, national ratio, the national table divided by length of, with the help of this formula you just get the language ratio, how much percentage of people they can speak this particular language, okay? Similarly expected also, you just use this data to get the expected count. Then you use this chi-square stat, okay, the same formula, observed minus expected whole square by expected, then summation, okay? You print those values, then you compute your critical value. If you want to compute the critical value, you need to use this function chi-square dot ppf. With the help of this critical value and chi-square value, you can able to decide your hypothesis, okay, whether you need to accept it or you need to reject it. Otherwise, another way is you compute the p value. Based on the p value and alpha value, you can able to do it, okay? So this is some other example to check the for chi-square test, okay? So, and then, okay, so now we will move on to the next concept, that is ANOVA test, okay? We will see one simple example for ANOVA. So we have two different types of ANOVA test, okay? One is one way ANOVA, another one is two way ANOVA. First we will see one way ANOVA test. So I will give one example, okay, one simple example for one way ANOVA. So initially I told so this ANOVA test basically meant for numerical kind of data, okay, same thing. So what I am doing is I have the packages. I am creating sample data for ANOVA test. Okay, you just assume that there will be 3 schools are there. These are the exam scores for 3 different schools. Okay, school A, they have exam score 85, 90, 88, 92, 85, and then school B 78, 80, 70. These are the some kind of scores. Okay, exam scores, and then school C we are having. Okay. So what we will do is, okay, so we need to perform ANOVA test, right? So now if you want to perform ANOVA test, okay, you just call, okay, stats dot, this is the library you need to use, stats dot f and score. This is one way ANOVA you are applying. Okay, later I will tell you what is two way ANOVA. Okay, so first one way ANOVA means you need to call one way ANOVA, then you give this data, school A data, school B data, and school C data. Then you will get these values, f statistics value and p value directly. Then you just run this one. Okay, so what will happen if you run this one? So you will get these values, f static value and p value. So based on this f statistical value and p value, so if your p value is less than your alpha, then you can accept that the group mean. You can make some interpretations. Okay, this just I will give some. So these are my f static value and p value. So for example, if you want to make any hypothesis testing decisions, for example, if my p value, okay, if my p value is less than 0.05, at least one group mean is significantly different. So what does it mean is, so we have 3 groups, right? School A, school B, school C. This mean of this data, okay. So if p value is less than 0.05, so now you just observe carefully, I am interpreting these results. Okay, so you know p value, in this case we got the p value as 0.03. For example, if it is less than 0.05 means, the meaning is at least one group means at least one school of mean data is significantly different. Okay, for understanding you just, okay, so the other case is if p value is greater than 0.05. So now in this case the p value is 0.0, I mean 7.03. Now we fail to reject the null hypothesis. These are the, so we are not rejecting any null hypothesis. All group means are equal. By observation you can say also. Okay, this group mean is equal. Okay, so this is one way ANOVA test. Any doubts in this simple example? This is one group. If you want to, you just compute the mean value. Mean means like average. Okay, 85 plus 90 plus 88 plus 92 plus 85 by 5, you will get some average. If you observe more or less all 3 schools average is less. Okay, for example, if I have data like this, okay, let's see, if I have data like this, in one school they got the score value 70, instead of 70 they got 7, 8, 9. Okay, then we have this kind of data. Now you say, okay, can you able to accept all 3 schools data? Like there is some criteria, I mean whether the particular school they got good results or not. You have some query. Can you able to accept it? School B has having different mean value, right? So if you run this one, okay, let's see what will happen. So I'm just giving, okay, so in this case this is varying, right? You just assume some hypothesis here, you try to reject this group. Okay, this group school value. Okay, this is F one way ANOVA test. If you want to do one way ANOVA, you need to call F one way. Similarly, I will explain two way ANOVA example. Okay, so when you are going to use two way ANOVA test means, so I will tell you. So there is some dependency is there in categorical and numerical data. With the example, I will explain the. So this is example for two-way ANOVA. So you have a data, okay, weight loss is there. For example, if you want to lose your weight, there are two things, okay. You need to do diet and then you need to do exercise. These are the two parameters to lose your weight, okay. One is diet, another one is exercise. You are having different diet, okay, A, B, C. These are the diet types, and then you are having exercise. They are doing exercise or not, yes or no, okay. So this is two-way ANOVA. What it is doing is for weight lossing, it is considering the both, okay, diet and exercise. See here, this is okay. This is one two-way ANOVA. You need to perform two-way ANOVA. So there is a model called OLS model. We are using the standard model, okay. You just refer what is OLS whenever you are getting time, okay. So we are using one model to compute, okay. So you have some sample data like this: weight loss 5 kilos, 7 kilos, 6 8 kilos, 9 kilos, 10 kilos. If you are having this kind of data, because these two, diet and exercise, are proportional to this weight loss, okay. Or sometimes, okay, is there any one diet also, it will reflect it, okay. In such cases you need to consider both, okay. So that's why if you are using these two features for weight loss, you are going to call this kind of computation will be two-way ANOVA, okay. So you just try to get some examples, okay, and then you solve these examples, okay. So with this, any questions? So if you don't have any questions, I will stop here, okay. You take some examples for ANOVA and Chi-score test from Google or any exercise problems or assignment problems. You try to solve it, okay. So if you don't have any questions, I will stop here. We will continue in next week, okay. Okay. Thank you all. Good night. Any questions? Okay. Bye.